Hello, welcome to everyone. I, Poonam Sharma, welcome you all to another session of Chemical Reactions and Equations chapter of class 10. In previous class, I have discussed about reactions like thermal decomposition reaction, photochemical reaction, decomposition reaction, displacement reaction, double displacement reaction, neutralization, and precipitation reactions. Now there are more reactions which I'll discuss with you in today's class, and today I'm going to discuss with you oxidation and reduction reactions. First, I'll discuss oxidation reaction in detail. Oxidation reaction is that kind of reaction in which there is addition of oxygen or removal of hydrogen takes place. So, oxidation reaction is that in which either we are adding oxygen or we are removing hydrogen. Apart from this, in oxidation reaction, there is a loss of electrons also takes place. I'll give you example of oxidation and reduction reactions later. First, I'll discuss about what type of reactions they are and how can we define them. So, oxidation reaction can be defined the reaction in which we remove oxygen we add oxygen or remove hydrogen, or there is loss of electrons. So there are three conditions for the oxidation reaction, students: addition of oxygen, removal of hydrogen, or loss of electrons. So these are three conditions when an oxidation reaction takes place. For example, if I'll just write here copper. When it is reduced to copper ions, it is losing 2 electrons. So here loss of electrons is take place. So this kind of reaction is an oxidation reaction. Now comes to reduction reaction. It's just opposite of the oxidation reaction. In reduction reaction, there is addition of hydrogen or removal of oxygen. Apart from this, there is gain of electrons. So as you can see, these two reactions are opposite to each other. So in oxidation, addition of oxygen, removal of hydrogen, or loss of electrons. These three things occurs in oxidation reaction. It's not necessary that every time all these three conditions exist. Either one condition or two conditions can exist. So that kind of reaction is known as oxidation one. And the substance which is from which there is a removal of hydrogen takes place, or addition of oxygen takes place, or loss of electrons takes place. So that element or compound is known to be oxidized. Next is reduction reaction. As I told you, reduction reaction is just opposite to that of the oxidation. Here, addition of hydrogen takes place, removal of oxygen takes place, or gain of electrons takes place. So this is a reduction reaction. And the example is like chlorine. Chlorine is gaining 2 electrons. Just right here. It is gaining 2 electrons and it becomes chloride ion. So this is a reduction reaction. Here you can see 2 electrons are gained by this chlorine, and here 2 electrons are lost by copper. So this is a difference between these two types of reactions, oxidation and this reduction reaction. And they are both opposite to each other. The next is before I'll start with another kind of reaction, I'll explain few more terms to you. Oxidizing agent and reducing agent. The oxidizing agent is that substance which gives oxygen for oxidation or removes hydrogen. Just now I told you, when any oxidation reaction takes place, if from any particular element or compound oxygen is removed or hydrogen is removed or loss of electrons is there, so that substance is known as oxidizing agent. If you'll see here loss of electron takes place from copper. So copper is an oxidizing agent in this reaction. And reducing agent is that agent from which we are adding hydrogen or removal of oxygen takes place or gain of electrons. So those substances are known as reducing agent. Sometimes this oxidation reaction and reduction reaction takes place simultaneously. What does it mean? It means when these both reactions are taking place together, then what do we call that kind of reaction? Yes, this kind of reaction is known as redox reaction. So redox reaction is that reaction in which oxidation and reduction reactions take place together. So that kind of reaction is known as redox reaction. And here you can see there is one reaction in front of you, copper oxide. When reacts with hydrogen, it results in the formation of copper and water. As you can see here, in this, copper oxide changes into copper. It means here we are removing oxygen from copper. And if you remember, when we are removing oxygen, so it means this is reduction reaction takes place here. And this copper is the reducing agent, because from this copper oxygen is removed. So in reduction reaction, if the oxygen is removed or that substance which is responsible for removing that oxygen is known as reducing agent. So here it undergoes, this copper oxide undergoes reduction reaction, and copper is known as reducing agent. Now let's see hydrogen. Hydrogen is changing to water. So here oxygen is being added to hydrogen. So it means here oxidation reaction takes place. And when we are adding oxygen, so it means this hydrogen acts like an oxidizing agent. So this is reducing agent and this is oxidizing agent. And when these two reactions takes place together, it is a redox reaction. I hope this is clear to everyone. I'm repeating again because this is very important topic, very important reaction. So when oxidation reaction and reduction reaction takes place simultaneously, that kind of reaction is known as redox reaction. And when you are giving an example of redox reaction, you can give this example and then you can explain which one is the reducing agent and which one is the oxidizing agent. I'll just explain one more thing to you in this redox reaction. See here, red means reduction and OX means oxidation. So it's easy for you to remember it. When these two reactions takes place together, we call it redox reaction. So redox reaction, when two reactions are taking place and the substance which get reduced is known as oxidizing agent, and the substance that getting oxidized is known as reducing agent. Another example of redox reaction is zinc reacts with copper. And here you can see zinc atom loses 2 electrons. When it loses 2 electrons, it means it is oxidized to zinc ions. And here copper is gaining 2 electrons and it is reduced to copper atom. And another example, just now I have explained this example to you. In this, copper oxide is reduced to copper. So oxygen is removed from it, from this copper oxide. And here oxygen is added. So these kind of reactions are known as redox reactions. Now next type of reactions are exothermic and endothermic reaction. Exothermic, it means when energy is released. So reaction which produces energy, exit, removing energy, which produces energy are known as exothermic reaction. And when most of the decomposition reaction takes place, they are mostly exothermic because energy is released during decomposition reactions. Respiration is also an example of exothermic reaction because when we respire, we release energy. That energy is utilized by our cells for performing various activities in our body. So respiration is also known as exothermic reaction. It's a kind of exothermic reaction. An example of exothermic reaction is given here. As you can see, this is photosynthesis when takes place. When glucose combines with oxygen, it releases carbon dioxide gas. This is this respiration. When we are respiring, we are utilizing glucose and oxygen, which results in the release of carbon dioxide gas, water and energy. And this energy is utilized by our cells. Another example of exothermic reaction is when quicklime, or another name of quicklime is calcium oxide. So when calcium oxide reacts with water, it results in the formation of slaked lime, or we call it calcium hydroxide. And when this reaction takes place, it also results in the release of energy. So whenever there is energy release or production of energy takes place, we call it exothermic reaction. Then we have endothermic reaction. It's just opposite to that of exothermic one. In endothermic reaction, heat energy is absorbed and decomposition of calcium carbonate. Here, when calcium carbonate breaks down into calcium oxide and carbon dioxide, here heat is absorbed by it. So this kind of reaction is known as endothermic reaction. As you can see, endothermic and exothermic, they both are opposite to each other. And what kind of question can come in exam? How is endothermic reaction different from exothermic reaction? In this kind of question, simply you need to write the definition of exothermic and endothermic reactions, or with the help of example, you can explain it by giving one example of each. So you can write this answer. Now there are certain effects of oxidation reactions in our daily life. And those reactions are corrosion and rancidity. First comes to corrosion. Corrosion is that process in which there is slow conversion of metals into undesirable compounds or substances due to their reaction with the oxygen. So when any substance, any metal comes in contact with the oxygen, it results in the formation of new substance which has property entirely different from that of the metal. And this kind of reaction is known as chemical reaction, in which new substance is produced. And when we get new product or the new substance due to the result of corrosion, so here we are losing some sort of metals or some amount of metal when this corrosion reaction takes place. Example of such kind of corrosion reaction is rusting of iron. I hope you people have observed that when you keep any iron article, iron object in an open atmosphere, the color of iron changes in a 1 or 2 weeks or more than 2 weeks. Some brown color substance deposits on it. So that substance is known as rust. So when iron comes in contact with oxygen and water, which is present in the atmosphere, it results in the formation of rust. And we call it hydrated ferric oxide. As you can see in this picture as well. So this is how rust looks like. And that's the reason why we always paint any iron objects such as our doors, windows, if they are made of iron, with paint or green, so that no rusting takes place. And the question comes in exam on the basis of this corrosion and rusting is, what will happen if we keep iron object in open area? Name the process involved in it. As I told you, if you keep any iron object in an open area, it reacts with the oxygen and water vapors which is present in the atmosphere and results in the rusting. And the process involved in it is corrosion or rusting. And by the formula of rust, so formula of rust is this way. When the question comes at the formula of rust, so you need to write this one. No need to write complete reaction, only just write down the formula of rust. And when corrosion takes place or rusting takes place, it affects the metals because it weakens those metals. Such as when we make bridges or railings or ships which are made of iron articles, iron objects, so their lifespan becomes shorter due to this corrosion. So we use some method or we apply some method to prevent rusting. And these methods are by painting, by greasing and oiling, or by galvanization. So if we apply a coat of paint on iron object, it acts like a barrier between the iron and the oxygen and water which is present in the atmosphere. So This paint reacts like a barrier. It does not allow iron to come in contact with the oxygen and water. So it prevents the iron objects from rusting. Another method is greasing and oiling. Either we can apply oil or we can grease it with paint or with any lubricant. They also act like a barrier so that iron object doesn't come in contact with the oxygen and the water. Or by galvanization. Galvanization is that process in which we apply a coating of zinc over metal. Coating of zinc over iron is known as galvanization. Because when we apply this coat of zinc over iron, so iron directly cannot come in contact with the oxygen and water. So it prevents from rusting. So these are methods which we generally use to prevent iron objects to get rusted. And how this corrosion of copper takes place. I hope you people have observed whenever you keep any copper substance in an open atmosphere, so somewhat greenish coating you people have observed. So this greenish coating, this greenish coat which we observe on the iron, this metal or object, it is due to the corrosion. Because copper comes in contact with oxygen and water, so it results in the formation of green coating, which is copper carbonate, when we expose this copper to air. And this type of reaction, this is the reaction takes place when copper comes in contact with carbon dioxide, oxygen and water. So this green covering, as you can see in this picture, this is copper carbonate. And this is known as corrosion of copper. Now similarly, silver metal also gets oxidized when we keep silver objects or any silver article. We use silver for making ornaments also. Although silver is less reactive, but it has tendency to react with oxygen. It will take time to get react. And the shiny appearance of silver becomes dull after a certain span of time when it continuously comes in contact with air. So when this silver comes in contact with air, it results in the formation of silver sulfide. And what is present in air which results in the corrosion of silver metal? This is hydrogen sulfide gas. So when silver comes in contact with hydrogen sulfide gas, it results in the formation of silver sulfide and hydrogen gases evolve. It's extremely important reaction. As you can see in this picture, this is made of silver, and when this silver comes in contact with air, the shiny coating of this silver metal becomes dull. It becomes dull after a certain period of time. Now, what kind of questions can come in exam? Let's see here. Question number 1 is, a silver article turns black when kept in the open for a few days. Give reason for this change. Any idea? Yes, just now I told you, when iron article comes in contact with air, in which hydrogen sulfide gas is present. So the coating of the silver turns black, which is silver sulfide. And the next question is, name the phenomena involved in turning of silver into silver sulfide in the above question. And the name of the process or the phenomena is corrosion. Another important method is rancidity. Rancidity is, you people have observed sometime when you, especially during summer season, when you leave your food in an open area, you are not keeping that food in refrigerator. After a certain period of time, there is some foul odor starts coming from that food. Have you ever observed it? I observe it so many times, and especially during in summer season, it stings a lot. And this change in the taste and color of food material, because that food contains some fat and oil. So when we keep it in open atmosphere, it comes in contact with air for a certain period of time. So this process is known as rancidity. So rancidity is a process in which the taste and odor, the smell of food changes, which contains fat and oil when we are exposed to air, is known as rancidity. And the reason for causing rancidity is because the fat and the oil which is present in food, it comes in contact with the oxygen, and the oxidation reaction takes place. So it means oxidation doesn't affect only metals, it affects food as well. And there are certain methods to prevent rancidity. By adding antioxidant, by vacuum packing, replacing air by nitrogen, refrigeration of foodstuff. First is by adding antioxidants. There are two antioxidants, that is BHA, that is butylated hydroxyannulose. This is one antioxidant. Another antioxidant is BHT. Again, this is butylated hydroxytoluene. So these are two antioxidants. When we add these antioxidants in any of the food material, it increases their storage life. They doesn't allow the growth of microbes in a food material. As a result, our food will not get spoiled, because when this food comes in contact with oxygen, in oxygen germs are present, microbes are present, and due to this, it results in the growth of those microbes. So if we are adding these antioxidants, BHA and BHT, so we prevent our food from rancidity. Next is vacuum packing. Sometimes you observe that some food materials are packed in airtight containers. And the reason for packing them into airtight container is to create a vacuum inside it, so that oxygen cannot enter into that food and it prevents it from this rancidity. Next is replacing air by nitrogen. Sometimes you get disappointed when you go to market and buy chips packet. So in those chip packet, the size of the packet is quite very large, but sometimes, and the amount of the chips which are present in that packet are very less. I always get disappointed. But the reason for this is we are replacing the air by nitrogen. And the purpose of adding nitrogen in that packet in which chips are present is so that those chips doesn't come in contact with the oxygen, and it prevents the rancidity. And if they will not come in contact with oxygen, no oxidation takes place, Next is refrigeration of foodstuff. When we keep our food into refrigerator, there also we can prevent it from rancidity, because oxygen cannot enter, or it does not allow the growth of microbes under that low temperature. So these are the methods to prevent rancidity. Now, what kind of questions can be asked by examiner in exam? First is, can rancidity be retarded by storing foods away from light? And the answer is, in the absence of light, the oxidation of fat and oil present in food is slowed down. Hence, the development of rancidity is retarded. So, yes, in the absence of light, the rate of oxidation is also reduced. Next is, how does food become rancid? Food becomes rancid when fats and oil which are present in the food material comes in contact with the oxygen. Next question is, which gas is filled in the chips packet to prevent rancidity and why? And the answer is nitrogen gas. Because this nitrogen gas is inert and it prevents the oxidation of oil. So next time, please don't get disappointed when you see that chips packet, because it's filled with nitrogen gas. It's used to prevent your chips so that they'll not become rancid. So I hope you like the session, and this is end of the chapter. In next class, I'll discuss few important questions from this chapter. So thank you everyone and have a nice day.